Addressing unsafe practices, specifically regarding arc flash hazards, requires a multifaceted approach. It is imperative to emphasize the potential consequences of arc flash explosions, underscoring the likelihood of serious injury or even death. Visual aids, such as images or videos depicting the aftermath of arc flash incidents, can be particularly impactful. Quantifying the potential financial repercussions of such events, including medical expenses, equipment damage, and legal liabilities, can also resonate with decision makers. Citing industry regulations and standards is another crucial step. Referencing NFPA 70E, which is electrical safety in the workplace, is paramount, as this standard provides comprehensive guidelines for mitigating electrical hazards. Highlighting specific sections of NFPA 70E that directly address the unsafe practices in question can strengthen the argument. Additionally, referencing other relevant standards, such as those published by the Institute of Electrical and Electronics Engineers, or IEE, or the American National Standards Institute, or ANSI, can further reinforce the importance of adhering to established safety protocols. Providing statistics and data can also be persuasive. Sharing statistics and case studies that demonstrate the consequences of arc flash explosions can illustrate the real-world impact of these hazards. Data from organizations such as the Electrical Safety Foundation International, or ESFI, and the Bureau of Labor Statistics, or BLS, can provide compelling evidence of the frequency and severity of electrical incidents. Whenever possible, tailor the statistics and case studies to the specific type of equipment and operations involved in a workplace. Offering alternative solutions is essential. Presenting viable alternatives to manually closing motor starters can demonstrate a proactive approach to safety. Explore the feasibility of installing hand/off/auto, or HOA switches, which allow for safe local control of motors. Investigate the use of remote start/stop push buttons, which enable operators to control motors from a safe distance. Consider implementing other engineering controls, such as arc-resistant switchgear and current-limiting fuses, to further reduce the risk of arc flash incidents. Seeking support from higher management may be necessary. If attempts to address the unsafe practices at the immediate management level are unsuccessful, escalating the issue to a higher level management can be a viable option. Prepare a comprehensive presentation that outlines the potential risks, the relevant industry standards, and the proposed alternative solutions. Clearly articulate the benefits of implementing safer practices, including reduced risk of injury, improved employee morale, and compliance with regulatory requirements. Furthermore, training resources and videos on arc flash explosions can significantly enhance understanding and awareness. NFPA 70E training modules provide comprehensive instruction on electrical safety principles and practices. These modules cover a wide range of topics, including arc flash hazard analysis, personal protective equipment, or PPE, and lockout/tagout procedures. Arc flash hazard analysis and mitigation videos demonstrate the process of identifying and mitigating arc flash hazards in the workplace. These videos often showcase real-world examples of arc flash incidents and provide practical guidance on how to prevent them. Arc flash safety training videos offer a general overview of arc flash hazards and safety precautions. These videos can be used to educate employees on the importance of following safe work practices and using appropriate PPE. OSHA resources on arc flash explosion hazard management provide guidance on complying with OSHA regulations related to electrical safety. These resources include fact sheets, training materials, and enforcement guidance. Additional tips include the following. Firstly, be persistent and do not give up. Changing ingrained behaviors can be a challenging process, and it may take time to convince others of the importance of safety. Be prepared to reiterate the message and provide ongoing education and training. Secondly, provide ongoing education and training. Regularly update employees on the latest arc flash safety practices and technologies. Conduct refresher training sessions to reinforce key concepts and address any questions or concerns. Encourage employees to participate in industry conferences and workshops to stay abreast of the latest developments in electrical safety. Thirdly, empower employees to report unsafe practices. Create a culture of safety in which employees feel comfortable speaking up if they witness unsafe actions. Establish a clear and confidential reporting system for employees to report concerns without fear of reprisal. Investigate all reported incidents promptly and take corrective action as needed. Fourthly, reward safe behavior. Recognize and reward employees who demonstrate safe work practices. Publicly acknowledge employees who go above and beyond to promote safety in the workplace. Implement incentive programs to encourage employees to adopt safe behaviors and participate in safety initiatives. Finally, create a culture of safety. Make safety a priority in all aspects of the company's operations. Integrate safety considerations into all decision-making processes. Establish clear safety policies and procedures and ensure that they are consistently enforced. By fostering a culture of safety, the organization can create a safer and more productive work environment. To elaborate further on NFPA 70E, it's a crucial standard for electrical safety in the workplace. It provides guidelines and requirements for protecting employees from electrical hazards, including arc flash and shock. The standard is updated regularly to reflect the latest advancements in electrical safety technology and practices. Understanding the key requirements of NFPA 70E is essential for ensuring a safe working environment for electrical workers. One key aspect of NFPA 70E is the requirement for conducting arc flash hazard analyses. An arc flash hazard analysis is a study that determines the potential arc flash hazards present in an electrical system. The analysis identifies the incident energy, the arc flash boundary, and the required personal protective equipment, or PPE, for each task. The incident energy is the amount of energy that a worker could be exposed to during an arc flash event. The arc flash boundary is the distance from the arc flash source at which a worker could receive a second-degree burn. The PPE is the clothing and equipment that workers must wear to protect themselves from arc flash hazards. NFPA 70E also requires employers to provide arc flash training to employees who work on or near energized electrical equipment. The training must cover the hazards of arc flash, the requirements of NFPA 70E, and the proper use of PPE. Employees must be trained on how to identify arc flash hazards, how to avoid arc flash hazards, and what to do in the event of an arc flash. Furthermore, NFPA 70E mandates the use of appropriate PPE when working on or near energized electrical equipment. The type of PPE required depends on the incident energy level. PPE can include arc-rated clothing, gloves, face shields, and helmets. Arc-rated clothing is designed to protect workers from the thermal effects of an arc flash. The clothing is made from flame-resistant materials that will not melt or ignite when exposed to heat. Gloves are used to protect the hands from electrical shock and burns. Face shields and helmets are used to protect the face and head from arc flash debris. NFPA 70E also requires employers to implement lockout/tagout procedures to prevent accidental energization of electrical equipment. Lockout/tagout procedures involve disconnecting electrical equipment from its power source and locking or tagging the equipment to prevent it from being accidentally turned on. Lockout/tagout procedures are essential for protecting workers from electrical shock and arc flash hazards during maintenance and repair activities. In addition to NFPA 70E, OSHA also has regulations related to electrical safety. OSHA's electrical safety regulations are found in 29 Code of Federal Regulations, or CFR, Part 1910.301 through 1910.399. These regulations cover a wide range of electrical safety topics, including wiring methods, grounding, and PPE. OSHA's electrical safety regulations are designed to protect workers from electrical hazards in the workplace. OSHA also has specific regulations related to arc flash hazards. These regulations require employers to assess the arc flash hazards in their workplaces and to take steps to protect employees from those hazards. OSHA's arc flash regulations are based on NFPA 70E. Understanding and complying with both NFPA 70E and OSHA's electrical safety regulations is essential for creating a safe working environment for electrical workers. Failure to comply with these regulations can result in fines, penalties, and even criminal charges. To further expand on alternative solutions, consider implementing remote racking systems. These systems allow technicians to operate circuit breakers from a safe distance, minimizing exposure to arc flash hazard. Remote racking systems are particularly useful for high-voltage circuit breakers, where the potential for arc flash is greater. Also consider using infrared thermography to detect potential electrical problems before they lead to arc flash events. Infrared thermography is a non-destructive testing method that uses infrared cameras to detect heat patterns in electrical equipment. By identifying hotspots, technicians can identify potential problems such as loose connections, overloaded circuits, and insulation breakdown. Addressing these problems before they escalate can prevent arc flash incidents. Furthermore, consider implementing zone-selective interlocking, or ZI, schemes in electrical distribution systems. CSI is a coordination method that allows circuit breakers to communicate with each other and trip selectively in the event of a fault. This minimizes the amount of equipment that is de-energized during a fault, reducing the potential for arc flash. CSI can also improve system reliability and reduce downtime. Another important consideration is the proper selection and installation of overcurrent protective devices, or OCPs. OCPs, such as circuit breakers and fuses, are designed to protect electrical equipment from overloads and short circuits. Selecting the correct OCP for a particular application is essential for ensuring that the equipment is properly protected. The OCP must be sized to handle the expected load current and must have an interrupting rating sufficient to handle the available fault current. Proper installation of OCPs is also crucial. OCPs must be installed in accordance with the manufacturer's instructions and applicable electrical codes. Poorly installed OCPs can fail to operate properly, increasing the risk of electrical hazards. In addition to engineering controls, administrative controls are also important for mitigating arc flash hazards. Administrative controls include work practices and procedures that are designed to reduce the risk of arc flash incidents. Examples of administrative controls include developing and implementing written safety procedures, providing arc flash training to employees, and conducting regular safety audits. Written safety procedures should outline the steps that employees must take to safely perform electrical work. The procedures should cover topics such as arc flash hazard assessment, PPE requirements, and lockout/tagout procedures. Arc flash training should be provided to all employees who work on or near energized electrical equipment. The training should cover the hazards of arc flash, the requirements of NFPA 70E, and the proper use of PPE. Regular safety audits should be conducted to ensure that employees are following safe work practices and that the safety procedures are effective. The audit should be conducted by qualified personnel who are familiar with electrical safety requirements. Finally, it is important to emphasize the importance of continuous improvement in electrical safety. Electrical safety is an ongoing process that requires continuous monitoring, evaluation, and improvement. Organizations should regularly review their electrical safety programs and procedures to identify areas for improvement. They should also stay abreast of the latest advancements in electrical safety technology and practices. By continuously improving their electrical safety programs, organizations can create a safer and more productive work environment for their employees. When choosing personal protective equipment, or PPE, for arc flash protection, several factors must be considered to ensure adequate safety. Firstly, the arc rating of the PPE is paramount. The arc rating, expressed in calories per square centimeter, or cal/cm squared, indicates the level of protection the PPE provides against thermal energy generated during an arc flash. The arc rating must meet or exceed the calculated incident energy level for the specific task. Secondly, the fit and comfort of the PPE are crucial for ensuring that workers will wear it consistently and correctly. PPE that is too tight or too loose can be uncomfortable and restrict movement, increasing the risk of accidents. The PPE should be properly sized and adjusted to fit each worker. Thirdly, the type of PPE required depends on the specific task and the level of hazard involved. At a minimum, arc-rated clothing, gloves, face shields, and helmets are typically required for arc flash protection. In some cases, additional PPE, such as hearing protection or respiratory protection, may also be necessary. Fourthly, the maintenance and inspection of PPE are essential for ensuring its continued effectiveness. PPE should be regularly inspected for damage, wear, and contamination. Damaged or worn PPE should be repaired or replaced immediately. PPE should also be cleaned and stored properly to maintain its protective properties. To dive deeper into the practical application of arc flash hazard analysis, consider the following scenario involving a 480 volts motor control center, or MCC. The first step is data collection. Gather all relevant information about the MCC, including the voltage level, available fault current, upstream protective devices, and cable lengths. This information is typically found on equipment nameplates, electrical drawings, and coordination studies. The second step involves determining the arcing fault current. Calculate the arcing fault current at the MCC using appropriate software or calculation methods. The arcing fault current is the current that flows during an arc flash event. The third step is calculating the incident energy. Calculate the incident energy at a specified working distance from the potential arc flash source. The incident energy is the amount of thermal energy that a worker could be exposed to during an arc flash event. The working distance is the distance between the worker's face and chest and the potential arc flash source. The fourth step involves determining the arc flash boundary. Calculate the arc flash boundary, which is the distance from the arc flash source at which a worker could receive a second-degree burn. The arc flash boundary is determined based on the calculated incident energy level. The fifth step involves selecting appropriate PPE. Select PPE with an arc rating that meets or exceeds the calculated incident energy level. Ensure that the PPE is properly sized and fitted to the worker. The sixth step involves labeling the equipment. Label the MCC with the calculated incident energy level, arc flash boundary, and required PPE. The label should be placed in a conspicuous location so that workers are aware of the potential arc flash hazards. Finally, train personnel. Provide arc flash training to all personnel who work on or near the MCC. The training should cover the hazards of arc flash, the requirements of NFPA 70E, and the proper use of PPE. Regularly update the training to reflect changes in the electrical system or safety procedures.